So, in 1984, a 12-year-old kid named Elon got a SpectraVision computer. And it was a SpectraVision 318. It was one of the basic models of the SpectraVision series. It had this all quirky keyboard that was impossible to type on, and it had this little hole beside the keyboard that you could use as sort of a keypad, but it had also this little red plastic thing that you could put down in the middle, and it became a joystick. And as every 12-year-old kid, I guess Elon, in his first meetings with Microsoft Extended Basic, which was part of the ROM on this one, started writing something akin to the code we're seeing running on the screen now. But by the time of December that year, his programming chops had gotten way, way better. And back then, in 1984, one way to distribute computer programs was through magazines. So what you would do is that you would print out the code and send it into some sort of magazine, and they would print it, and you would buy the magazine, take it home, and then type the code back into your computer, and if you did everything correctly, you could run it. So what you're looking at now is the code that 12-year-old Elon wrote and sent into PC and Office technology that was printed in the December 1984 edition. And I would just like to bring your attention to his very economic use of spaces in this one. There are virtually none, so everything runs continuously. So 12-year-old Elon had learned to trust his basic interpreter. And when you got to the end of this and ran this thing, you would see the fantastic game Blaster. It looks kind of familiar. It was a game where you had a spaceship that was carrying deadly hydrogen bombs and had something called status machine beams that could shoot you down. It's a fairly basic game. But I think that some of the AI in this one still lives on in the Tesla autopilot. And this was written by Elon Musk, 12 years old, 1984. He was on the verge of its teenage years. So he's a bit young to be part of this talk, because this is the marvels of teenage engineering. And we will be going around the world, meeting loads of kids in their teen years, and see the amazing software that they built out of their bedrooms, while most other people hadn't even learned what a computer was yet. So, for those of you who have seen my previous talks the last few years here at the NDC, know that I tend to go a bit around the world in these talks. And this time we started out in South Africa, which is a bit scary given the circumstances today. Usually we've been a lot in America, but this year I'm glad to say that we go from South Africa to the Soviet Union. So this is the Electronica 60 computer, which was made by Electronica Voronezh in the Soviet Union in the 1980s. Now, this is basically a clone of a Western computer. Here in the West, this was known as the digital PDP-11. It was a 16-bit computer with an amazing 64 kilobytes of RAM. And this was the computer that the original Tetris game was written on. And Tetris was written by Alexei Paltsev, this guy, who is not a teenager. He was 29 at the time that Tetris was written. Tetris, by the way, was written in the Pascal programming language, which was sort of the national programming language of the Soviet Union. That was the one that was being used. They also had a Soviet translation of that, where all of the keywords were in Soviet Russian. I'm not sure whether Tetris was written in that or if it was written in the traditional English form of Pascal, but anyhow, Pascal was the language that was used. But had it not been for a teenager called Vadim Gerasimov, who was 16 years old, and that's Vadim there in the background on this photo, it's not entirely sure if Tetris would have been the breakaway success that it ended up to be. Vadim studied at Arkady Borashnovky, which was a high school in Soviet Russia. And at this high school, he was working with his maths and computer science teacher, doing something as advanced as writing an encryption program for MS-DOS. Now, Dmitry Pavlovsky, who was the assistant to the father of Tetris, and this gets a bit complicated, stopped by this high school and bumped into Vadim and saw how talented he was programming Pascal on the IBM PC clones they had available in Soviet Russia. So Pavlovsky brought Vadim with him and showed him the source code to some games he had written. These were sort of simple, basic games. And the day after he'd done that, Vadim came back with an MS-DOS version of one of the games that he had written just overnight. And this was sort of impressive. So Vadim was introduced to the father of Tetris, and he ported Tetris from the Electronica 60 to MS-DOS, and it was the MS-DOS version that made it through the Iron Curtain and became the legend that Tetris is today. Oops. It's sort of bad when you get malware in the middle of your talk. And this thing has a bit of history to it. So these days, these things are a bit pesky when you get them. Things were a bit nicer and easier at the beginning of the 1990s. So I want to tell you the story about a 17-year-old punk from San Francisco called Neil McAllister. Now, Neil was, as many teenagers are, a bit of a nuisance. His primary hobby was to blow up public telephones using firecrackers. But he also had an IBM XT clone computer at home. And the one thing he used that computer for was to dial up something called bulletin board systems. Now, bulletin board systems were like the social media of the day. They were computers you can phone up with a modem connected to your own computer. And if the line was free, you were able to connect. This was like a one-to-one connection. It was not a multi-user system. But he used to hang around at some of these bulletin boards. And at those bulletin boards, he met people who viewed themselves as elite hackers. And he was a bit annoyed by these people. Because he didn't really find it impressive to write computer viruses, which a few of these people were doing. So he started thinking a lot about computer viruses, and then suddenly there was a really badly named virus that was written by a Dr. Teresa Goody that came on to the scene around April 1990 that spread like wildfire. And it had the terrible name of AIDS, which is not something that is really funny to name a computer virus after. It wasn't a particularly good computer virus either. It had none of the smarts that computer viruses have been known to have later. It wasn't really sneaky at all. It didn't hide out on your computer in any way. It just went on infecting loads of files and corrupting them. And that virus was written in Turbo Pascal. It had no Russian connection, as you would guess with some of the malware today. Still written in Pascal. So one of the things that annoyed Neil McAllister was that this virus was very, very large in footprint. It was 16 kilobytes big. So you could very easily tell if a file was infected or not, because it instantaneously just blew up in size. So he wanted to do his own little virus. And he wanted that virus to be 666 bytes big, or small, you could say. And he named that after his favorite metal band, the legendary metal band Death, and their album Leprosy, which is another virus, but he thought that was a more interesting virus than AIDS, which I can agree with him. And this virus sort of infects files, and it becomes active every year on the Friday the 25th. So every time Friday the 25th appears, this happens. So the flashes that Hellraiser, it was inspired by the film Hellraiser, which just recently came out, on your screen. And whenever your computer reboots, it does the same thing over again. So this was the Leprosy virus. And this was a bit of a special virus because, as you might remember, Neil McAllister, he was fond of blowing up public phones. He didn't know anything about computer programming. But he went out and bought the Peter Norton Pink Shirt book, which at the time was the guide to programming anything on the IBM PC. Ironically, Peter Norton at the time was also making a fortune making antiviral software. So he sort of started that circle going. So this one taught Neil McAllister everything about how to sort of find the files, change them on the computer and so forth. Only one small detail though. The virus became rather big. He didn't really know how to fit this into 666 bytes, which was sort of a key to this thing he had going. But he found this. He found an article in the December 26th edition of PC Magazine from 1989, which had this small little snippet on how to write your own little C loader. And Neil McAllister had programmed this little virus of his in C. So having this one instead of the regular C loader managed him to get away with all of the sort of argument handling and so forth and just get the bootstrapping code in there. And naturally, this is the source code for this. For those of you well-versed in C, you can see that this is sort of straightforward C code. But he did a couple of interesting things as well. He camouflaged his virus, which he was one of the first people to do. So when he ran his little virus infector program, it just printed out something that looked like a real error message, but was not. It was just a red herring. And he went about not to infect too many files. So it would stay around, be sneaky, and it would only appear with this sort of hell-raising message every Friday, the 25th. The thing was that he had never heard of open source software, but he wanted to tell the world how he made his virus. So Neil McAllister was probably the first and last person in the world to write documentation for his virus. And this is it. This is the documentation for the Leprosy version 1 virus that he uploaded to some bulletin board systems around the world. That made all of the antiviral software developers aware of this virus within 24 hours, and it didn't really become such a nuisance, and it didn't really affect many people. Then he realized he hadn't managed to get this down to 666 bytes, so he did a second strain of this virus, the Leprosy strain 2. And he rewrote that in assembler entirely, managed to get the size down to what he wanted, uploaded this to a bulletin board, and forgot about it. Until a couple of years later, where the 40 Hex Underground magazine, which was dedicated entirely to writing viruses, in its first ever issue, had documentation on how the second strain of the Leprosy virus had managed to be that small, and how it had managed to stay camouflaged for so long, and how it managed to become an epidemic virus on PC computers back in the early 90s. So we can say that this guy, he managed to go viral on social media way before social media was a thing.
Confirmed it is investigating members of a Milwaukee area computer club and successfully tapped into the computer of the nuclear weapons research laboratory at Los Alamos, New Mexico, walking in under investigation, reportedly said breaking into the computer system was, quote, really easy to do. How easy was it? Very, very easy.
So, we're going to go back a few years, and we're going to go back to what enabled Neil McAllister to connect to the built-in board systems he did, and the time where modems were something that he used. Now, in 1983, the film War Games came out, and this sort of popularized in popular culture the myth of hackers, and made hackers sort of cool. Really cool, like Timothy Winslow here. Timothy was the nerdy kid who went to the computer room at his school in every single break and sat around playing with the computers there. Together with Neil Patrick and a third that was not longer a teen, he had just turned 20, they started a gang. The street gangs in Milwaukee, where they were from, had names from the different streets in the town. So they were called the Nines, the Sevens, sort of based on what turf they were protecting. So they decided to call their gang the 411s, which was the area code for Milwaukee on phones, which made sense since they were dialing up using modems. Now, they met in an IBM-sponsored... What can you see now? Yeah. In an IBM-sponsored Explorer Scouts camp. So Explorer Scouts exploring computers rather than wild woods, so they could stay in a safe environment. So they met at an Explorer Scouts camp, and they started experimenting, inspired by what they did in the War Games film. And they wrote a piece of software to sort of automate dialing up every single phone number, first in the 411 area code, and see if they could connect to a computer at the other end. And whenever they connected, these were usually telnet computers, so they knew how to log in. You could try the password admin, which often worked at the time. And they started sort of increasing the radius where they tried dialing up numbers. And not after long, they had managed to connect into the Security Pacific National Bank, Baxter Travenol Laboratories, Canada Cement, Volcor Dynamics, which I don't know what is, Dupa Plumbing, a taxidermy shop, but most importantly, they connected to the Sloan Kettering Cancer Center, and then finally the military plant at Los Alamos. This naturally sparked the interest of the FBI. And they started hearing sort of weird clicks on their phone lines and so forth, until one day the FBI showed up at their houses, full on, thinking that they were going to arrest some sort of large criminal enterprise, Russian spies or whatever, finding these kids. One of them was still a teen. The two others were, at the time, over 18 years old. Neil Patrick went on all the talk shows talking about this, becoming sort of a celebrity, and was seen as the real-world incarnation of the main character from War Games. The others were in a bit more of a sticky situation, because they were actually indicted with this. But at the time, the United States didn't have any laws relating to computer crimes or hacking. So in the end, they were charged with making malicious phone calls, prank phone calls, and they got away rather easily. Later that same year, the US got its first laws against computer crimes, and you got these kids to thank for it.
Gutterommet. Og det jo vanskelig å være voksen I datahallen. Disse gutta her, mindreårige, noen over 18 år her, Ja, det 2 stykker, ja. Resten har alder på Øystein. Du er 17, og herren bak deg. Han er 16. Disse gutta, 16 år, startet firma på gutterommet. Powertech er navnet. Og Øystein. Hva er det du selger for noe?
Vi selger noe som er veldig nytt her i landet. Tilgang til internett.
Internett?
Internet. And I hope the non-Norwegian speaking people among us managed to read the subtitles on this. This is an extraordinary example of a 1990s Saturday night national TV entertainment here in Norway. This is a show from 1994, and the kids in here dropped out of high school earlier that year to start one of the first ISPs in Norway at a time where nobody had heard about the internet. There was one other company offering internet services in Norway at that time, and that company was started by professors at the University of Oslo. They got competition from these kids, 16, 17, and 18 years old. And these kids set up their operation with regular sort of PCs that they had at home, with their own modems and so forth, running it out of their bedrooms to start with, and then moving on to getting a more proper operation. They kept on doing it with limited hardware for a few years, but suddenly they grew much, much larger. And they wrote all of the software for this themselves. They wrote all of the billing software, all of the connection management things, all of the networking stuff, which you would think is rather hard. It's quite difficult to run a telco. But when you have the audacity and the arrogance that you have as a teenager, you can actually go or could go out and do something like that. In 2016, PowerTech was sold for an undisclosed amount of money to the leading fiber company here in Norway. But the turnover at the time was 121 million per year. So I guess we could say that the sort of teenage engineering operation that these kids were running out of their bedroom was quite a feat. But another thing that I noticed when looking through these old recordings of excellent 1990s Saturday night entertainment was that the skepticism towards the internet and technology probably was a bit ahead of its time.
På å finne ut en del småting om det, Lars. Vi gikk inn i bare en par-tre banker, og det var ikke lite som var registrert på Lars Østbjørn.
So, 1994, predicting the future there, which is probably something that you do when you're working for the Statistical Bureau of Norway. So, this might look familiar. It might look familiar if you've played Super Mario World 3, which is probably why this game is called Dangerous Dave in copyright infringement. So this is a game that was never released, but it's a part of the Dangerous Dave franchise that was started by John Romero, which is a fairly well-known name in the computer games industry. And the first game came out in 1998. At that time, Romero was 21, which we all know is not teenage. But the programmer of this was 16, 17 years old at the time, and it was John Carmack. And this thing is important because it changed a lot about how games were developed, and we're going to dive into some of the technical details. So for those of you coming to look at code, Just sit tight for a couple of minutes more. Because this changed everything. And this was also the start of ID Software, the legendary game company that would move on to give us Doom. But before we can talk about that, we have to have a small lesson in how computer games are made. So when you create sort of the levels, the backgrounds in these games, you do that using something called a tile sheet. So you have these little squares of graphics that are of the same size, and then you go around and you sort of tile them out, and you build up this little thing called a world, which is divided into all of these little squares, built up of this tile sheet. This might be the same thing as CSS sprites if there are any front-end developers amongst us. This is where it all came from. And one of the things that came out of this, which is sort of known story, is something called adaptive tile refreshment, which this is the code for. And the thing here was that one of the inventions that came out of this was that you realized how to keep track of where the characters, the sprites, had moved around on the background, so you didn't have to redraw the entire background. You can only redraw parts of it, which was a major invention because it made the games really faster. It made it run more smoothly. But that was not the most important invention in this. So this is the story that Wikipedia brings forward. But this thing enabled something entirely different, because the IBM PC did not really have very good hardware for doing graphics. But one of the changes was that on the extended graphics adapter, you had the possibility to increase the screen size beyond what was displayed on the screen. So you would get what you're seeing here. You would have the viewport, which was what you saw on the screen. And then you would have this little piece often on the edges of the screen. And this was one of the things that John Carmack discovered, that he could add this to the ends of the screen, and then he can manipulate the screen address, what the video graphics card in the PC would show. He could manipulate to move this to the sides. And then he just drew 2 lines of these tiles off and on the edges of the screen, and then used his tile refreshing technique to update this, which made him make a smooth side-scrolling game that had never been possible on the IBM PC before. And even if Wikipedia focuses on the story about the adaptive tile refresh, the Guinness Book of Records in 1991 got this right by naming Commander Keen and the Invasion of the Vorticons as the first ever smooth-scrolling PC game. That's worth a round of applause, guys. So that allowed them to run advertisements like this one. The IBM PC outshone the Amiga. And looking around, I guess some of you in the room had Amigas back in the days. Oh yeah, there were a few hands coming up there. And there were 2 computers that competed at the time that on paper were sort of similar. You had the Commodore Amiga, and you had the Atari ST. What was common between these two were that both computers had the Motorola 68000 processors in them, but the Amiga was technically superior to the Atari. And we could easily see this by doing a side-by-side comparison of the legendary Psygnosis game, Shadow of the Beast. This is a game from 1989. It was not written by teenagers, but you have on one side with the Commodore logo underneath the Amiga version, and you have the Atari ST version on the other side. And you can tell the difference. This is the same processor. The difference is that the Amiga had loads of graphics processors that made this look terrible on the Atari. This was the best they could do. That was the best that adults could make out of the game on the Atari ST. And one of the reasons why this fits so nicely side by side was that they didn't even have the processing power to play any music on the Atari version. So all the music we heard was from the Amiga version of this. It would take a teenager to change this. This is the Atari ST game Enchanted Lands. Released by Thalion Software, 1990. This game is programmed by 17-year-old Swede Nicholas Tisell. And we have all heard the stories of John Romero, as we just heard, who has been sort of talked about as one of the entrepreneurs who really changed game programming. Nicholas Tisell is an unsung hero. This sounds rather funky, but we have to move on. So we have to talk about the Atari ST. The Atari ST came with two different kinds of screens. You had the option by choosing the high-resolution black and white screen that gave you a resolution of 640 times 400 pixels with a refresh rate of 71.25 hertz. That doesn't really sound that amazing, but at the time that was the best you could do. Or you had the option of getting the color variety, which had the possibility of displaying 16 colors at the time out of a total 512 colors it was capable of using. But you have to sacrifice that for resolution, so you only got 320 times 200 as your resolution at 50 hertz. And the 50 hertz is important here. That's the switching rate of the electricity grid here in Europe. If we go to the United States, that increases to 60 hertz, and it was also capable of displaying the screen at 60 hertz. But what happened then was that it was vertically stretched, like this. And this takes us back to school, guys. We have to go to the School of Teenage Engineering again to learn about vintage technology and the kinds of screens we were using before LCD and flat screen monitors were around. So you might have seen this at museums, at your parents' house, or somewhere else. But this is sort of what a television used to look like back in the days. This was probably the set that people looked at the 1990s program that introduced PowerTech to the world back in 1994. This is a cathode ray tube. It's a pretty great name for something. It sounds really, really cool. It's even cooler in reality. So if you look at an intersection of something called a cathode ray tube, you have this thing. This is the screen, and at the end of this, the end without the cat, you have a ray gun, a cathode ray gun. And wow, doesn't that sound cool to have in your living room? You have an actual ray gun in there. So you have this cathode ray gun that fires a ray at an anode and then hits the fluorescent screen at the end, which, switching the electricity on and off or something like that, enables it to draw an image onto the screen. And then you have really powerful magnets, other cool stuff you can add to this, that enables you to sort of bend that ray to position where on the fluorescent screen it hits, which enables the television to draw an image from the left-hand uppermost corner, going to the right, moving line by line down, and you end up with something that appears on the screen. Now, this was common knowledge to this bunch of teenagers. This is a gang from Sweden called the Care Bears. Yeah, that's a great name, isn't it? Nicholas Tisell, as I talked about, is one of the people, the one with the red ring around him. The others are Anders Nilsson, Niklas Malmqvist, and Andreas Surkusk. These guys were wizards with pushing their Atari ST computers to the limits and beyond the limits. Because using those different resolutions and refresh rates that the different screens had, they were able to do something amazing. And right now we're going to go through the most mind-boggling part. This is also where we will see the weirdest code today. So if you don't understand a thing of this, no worries. It took a 17-year-old Swede to figure all of this out, so you have an excuse there. Motorola 68000 assembler, ladies and gentlemen. So the red line on the screen here is that cathode ray moving from the left to the right. And for every single line it drew on the screen, the processor had 512 clock cycles to perform things. Then it moved on to the next line. And if you knew how many clock cycles each machine code instruction took, you could start counting where along the line you were. And that's exactly what Nicholas Tesel was doing. So when he had gotten to this position where the red line is now, he did something interesting. He figured out, what if, asked himself the question, what if I switch the screen into 71 hertz, then wait a couple of clock cycles, then switch it back to 50 hertz again? What happens then? Lo and behold, the left-hand side border, the big black border around the screen, disappears, and he gets a larger canvas to draw on. Who would have known? Then you just wait and move along until you come a bit further along the line, and then you need to do something different. To avoid the television screen from exploding, you have to do the switch again. And this actually happened. Before they figured out how to do this, they had a TV set explode in his bedroom. I kid you not. So he did this, and when the refresh came all the way over to the other end, he switched to 60 hertz, waited a millisecond, and then went back to 50 hertz again. Lo and behold, the right side border opened up. And then he just had to do some more figuring out to do and to stabilize it all, and then he could just move on to the next step. And when he created a long list of different variations of doing this and did this for 5 to 8 lines, he was able to offset the screen, change where the video chip in the computer started drawing the screen to actually, and hold tight to your seats now, do software-based hardware scrolling on a computer with no graphics hardware. I'll say that again. Software-based hardware scrolling on a computer with no graphics hardware, which enabled him to move the screen smoothly sideways, which was exactly the trick he pulled off in this game for Italian software that he developed when he was 16 years old, 17 years old.
Ladies and gentlemen, rock and roll.
So August 1st, 1981, something really important happened. And nothing to do with computers, it had everything to do with music. MTV launched. And MTV would go on to change popular culture, and it would naturally influence computers as well. MTV had a show. It was the longest running show in MTV's history, called The Party Zone, that was on every Saturday night in Europe. It launched in 1988, and it presented modern dance music and things like this, psychedelic video clips from midnight and until 2 or 3 in the morning. After which it was time to come down and the chill-out zone came on. So this inspired some people to do something interesting. So this is on the Commodore Amiga. It's a demo made by a group of teen programmers known as Spaceballs. They're from Norway, from Østfold, Halden area. And yeah, someone from there in the room tonight, that's good. And they did this. It was sort of a music video. And this was something totally new at the time, because people had scroll text and so forth and such, but this time someone actually made something that resembled something that you could see on MTV. And MTV actually went on to show this at the Party Zone as well. So they sort of went full circle there. And the guy who programmed this was the 16-year-old we're about to meet now. So this is 16-year-old Paul Endre Endresen. He was the programmer behind the thing we just saw. And for those of you who are familiar with what they did, this is the actual footage from when they created the follow-up to what we just saw. So when they had made the first one, it was a breakaway success. And then they had to make the sequel to follow up that. And he took his girlfriend, who is the brunette here, and her friend out, set them up in front of a white wall on their local school, and just put them, Sing Hallelujah by Dr. Alban, I believe, and just had them dancing. And this is the original footage that they used to make this, which came out the year after the state-of-the-art thing we just saw. This is called Nine Fingers, was released December 29th, 1983. And what Paul Endre Endresen did when he had turned 17 at the time, was that he wrote digitization software that took the videos and turned it into the vector graphics we see here. That's pretty amazing work for a 17-year-old, I would say. And this was just amazing, and we'll come back to him in just a second. But we have to skip across to England and meet Dylan Cuthbert, who is an interesting character. Dylan Cuthbert got himself a ZX Spectrum computer when he was around 13 years old. And the one thing he didn't have was that he didn't have any games for that. So he had to write his own games. He said he wasn't even from Yorkshire. He wasn't a Yorkshire man, but he acted like one. No Monty Python fans in the room, I guess. Oh, you were lucky! So he started writing games for his ZX Spectrum computer, which was a fairly limited computer compared to the Commodore 64s and such that, and Apple IIs that programmers in the United States grew up programming. So he learned a lot about living with limited hardware. And when he was around 16 years old, he wanted to get a job in the games industry. So he wrote a little piece of software for his Commodore Amiga, which he had acquired at the time, with a rotating Argonaut software logo. Put it on a diskette, mailed it to Argonaut Software. The day after that arrived there, he got a phone call and was offered a job. And Argonaut Software were known for putting 3D engines in just about everything at the time. And when Dylan Cuthbert started working there, he did as any curious teenager would do. He was set to reverse engineer something, pull something apart. And the thing he was set to reverse engineer was the Nintendo Game Boy. Because Argonaut Software wanted to get in with Nintendo and make games for the Nintendos. But they didn't have any development kits. So he made his own development kit for the Nintendo Game Boy and wrote a 3D engine, which was the thing that Argonaut Software did. Only that Argonaut Software were mostly adults. Dylan Cuthbert was a 16-year-old kid. And he made this game called X for the Nintendo Game Boy and got noticed by Nintendo. So Nintendo flew him over to Japan, where he got to work with the teams at Nintendo to create this game. And this game is known as Star Fox. And it was the first sort of real 3D game for the Super Nintendo Entertainment System. You had sort of 3D-like games, such as Mario Kart, that came out the year before this, but that was due to a system in the Nintendo called the Mode 7 graphics, which change the width of the screen on every single scan line moving down. Does that sound familiar to you a lot? This was actual 3D graphics with real 3D polygons and so forth. And to make this happen on the extremely limited software that was in the Nintendo Entertainment System, they had to make a special chip that went on the game cartridge that you plugged in, and it was called the FX chip. That did all of the 3D calculations that were possible for this, and that chip was designed by Argonaut Software. Dylan Cuthbert was one of the lead designers of this. He had turned 18 at the time, and the chip is known as the Mario chip. It's the mathematical Argonaut rotation and input-output chip. So that chip went in a few games. One of the games nobody noticed was this one. Winter Gold was immensely delayed. This was meant to come out around the Olympics at Lillehammer in 1994. Didn't come out until 96, at which time most people had forgotten about the Super Nintendo Entertainment System and moved on. But does this look a bit familiar? This is programmed by Paul Endre Andersen, and he's using the same techniques as he used for programming his Amiga a few years earlier. Now he was 19, and he created this game. And it was a 3D game that looked like nothing like Star Fox. And the 3D graphics here were much more advanced. Thank you. Much more advanced. And the reason is that this is not really a 3D engine. He was using the techniques from his Nine Fingers production to create a 3D video, or a 3D video that you move through like an on-rails game. So that's Winter Gold for you. So what about those having even more limited hardware to play around with? Again, this is the game Shadow of the Beast in the amazing version that was made for the Commodore 64. Personally, I think this looks better than the Atari, at least the official Atari version of this. And the Commodore 64 was an amazing computer, but as people started pushing it to its limits and beyond its limits, the limited amount of memory in the Commodore 64 became a problem. A problem that Danish teenager Henning Andersen sought to solve. He went under the alias Einstein, and he created the Einstein assembler for the Commodore 64. This was something known as a cross-assembler. That meant that you wrote your code on a Commodore Amiga. You had a special cable that you connected between your Commodore Amiga and your Commodore 64, and you would assemble the code onto the Commodore 64 so you could use the entire memory, as your assembler didn't take up any memory footprint. He was around 16 years old when he wrote this. He distributed that along with schematics for making that cable. You had to make the cable yourself. At the time, it cost you 700 Danish kroner. 50 more if we were to use it with a television screen. That was sort of a joke because he was elite. That would be 1,200 Danish kroners today, and you had to make the cable yourself, but at least he invented this thing. Another legend, Jordan Mechner. He is mostly known for doing the Prince of Persia games, which he did when he was a bit into his 20s. I don't think that's a very interesting story. The source code is on GitHub. There was a book written about it if you want to learn more about the Prince of Persia games. It has even been made into a movie if you don't like reading books. I want to talk about his game Death Bounce, which was never released, which he created when he was 16 years old. And the interesting thing with Jordan Mechner was that he kept meticulous journals, writing down everything he ever did. So he kept a log of writing this game. And it starts out February 7th, 1982, where he has this idea. He has read something about producing random dots in a computer magazine. Sparks an idea in his head that he wants to turn this into a game. Then he starts thinking about how much money he can make. If he thinks that if he sells 1,000 copies, he'll make $4,500. If he sells 5,000, that will be 22,500. He is about to strike gold. He is about to become rich, and he motivates him to move on creating this game. He moves on to sort of stumble upon all of these sort of challenges you have. Writing this game in BASIC is too slow. He has to move on to do something in assembler instead. A few days later, he has to figure out how to do dual page animation to not make it flicker. But he has to discover all these things for his own, because there was no internet around. But he sits there in his room writing this game on his own and creating it. And as you can see, the result is rather amazing. And this all comes from him reading this issue of Creative Computer magazine from January 1981. And this is the article he came across, which explains how to create random dots. But the little text down in the right-hand corner, which you probably can't read, says, since these routines were written in BASIC, they run rather slowly. An obvious enhancement would to be a machine language implementation, which is exactly what Jordan Mechner did. He taught himself assembler programming to do this. And I find it sort of soothing that he has this journal entry, that he has a to-do list, and he needs to finish the game module, clean up the code, test, and then just do the last feature, finish, top, add the cursor, and so forth. So teenage engineering in the bedroom of Jordan Mechner was exactly like our projects at work. There was always something left to do and a to-do list that we never get to finish. This is not a teenager. This is 11-year-old Chris Mehera. And he wrote a game for the Apple iPad a few years back, which is the game you see here. He went on to give a TED talk about what he did. And in that TED talk, he was asked the question, how did you manage to do this? And he said, I just sat down and wrote the code, which is the way you build things. You sit down, you write the code. There isn't much code out there, so he might have had some help. Might. This is something I found on his GitHub. He has at least ambitions, because this is sort of a Swift code for iOS, hello world thingy. But he is going to destroy the world. Hello world, get destroyed. And I think that says something about the ambition of people starting out writing their own code. And that got me thinking. Because the stories that I've told today are mostly from a very specific era of our computing history. And most of these things are about kids that came of age around the early 90s. Sadly, there are no girls in here. And I tried to find the stories about girls who did this. There were none. And there were a couple of things happening at the time. At the time, at the end of the 1980s, was where things changed from IT becoming a boys' thing to do, from having loads of women employed there. The amount of women employed in the IT industry dropped sharply at the end of the 1980s, early 90s. Having computers at home were a boy's toy, which doesn't make sense at all. Today, we see some of the stories, and I tried to find some more current stories about teen inventors. And luckily, there are quite a few girls out there doing amazing things, coming up with amazing ideas to realize, and being able to assemble teams around them to actually put those ideas into becoming reality. But I had to draw the line somewhere, and I wanted to tell the story about kids going out and doing this on their own, and doing all of it on their own, from sort of that teenage go-for-it spirit that we all felt once. And to be sure that we can spark that spirit again, it's really important that we encourage kids these days where the computer comes with everything pre-installed. You don't have to sit down, write your own software. You have the App Store, so you don't have to type anything in from a magazine to have some simple game running on your computer. And you don't really have to learn about how the computer actually works. That we spend time with kids, teaching them about how computers work and how code works, and teaching the kids how to code, because that is important. I want to take you to Lakeside High School, late 1960s. And I want to tell you the story about two other pupils at school. Lakeside High School had gotten a computer room that the mothers at the school had sort of petitioned for it getting, and they had a computer terminal there, which allowed you to work against a central computer somewhere else. And two of the kids at that school were so amazed by this computer that they broke into their high school computer room and used that computer in the evenings. Eventually they were caught. First they were expelled from the school, but then the headmaster realized that maybe, just maybe, these kids have something to contribute. So he gave them a challenge. They could have their computer time back if they solved a problem for the headmaster. If they could solve his problem that he had two people working the entire summer through to set up the time schedule for the next semester, they could use the computer room as much as they wanted. And these two kids went in there day and night working on this problem, and they managed to solve it. One of them also wrote a little Easter egg in there so he could sit next to the girl he was fond of at his high school, and they got their computer time back. Those two were Bill Gates and Paul Allen, and it's a tale of ingenious teenage engineering that went on to become something much, much bigger. And I think that's an inspiring story to end with, to see just how far teenagers with the right kind of motivation can get. Ladies and gentlemen, this has been the marvels of teenage engineering. Have a great NDC party, and thank you all for coming. And I would love to talk to all of you about this later on. So you'll find me around. Thank you.